So good morning, everyone. First by Gemini call rules, and as Simon said, CMCL, the first acronym. So be braced for many more. CMCL stands for Computational Modeling Cambridge Limited, and I was just joking, there are no further acronyms. It's a pleasure to be here, and thank you to DNV, to Gemini team, Gemini call team, as well as Digital Twin Hub CPC. Today I would like to share with you some of our experiences and journey at CMCL with a specific energy dimension to these use cases, and they have all been powered by the world of TAR. Again, in the spirit of Gemini call, which means no sales pitch, I think what I would like to do is to introduce the company via a use case directly. What you see here is on the left is the excavator, and the engine in there can go into multiple applications. So the excavators can be used in forestry, construction, rescue relief work, as well as the same engine can go into gensets for power and backups or fuel-based backups. So the problem that we were faced is the emissions testing and compliance for these engines, because they go into multiple operations. This is quite expensive. And the question we were posed is, how can we reduce the reliance on measuring everything and thereby save development costs? What you see here is a map on load speed of that engine. So these operating points, and the engine has to be run in a test cell for days and days at each operating point, gathering lots of data. So we developed a digital workflow. And again, thanks to the previous speakers for describing what stochastic models are. So I don't have to go into details, but we wrote software to basically combine stochastic models for engine operations, combine that with data-driven and machine learning workflows. Thereby, what we called then ambitiously as a thermodynamic digital twin. This digital twin capable of evaluating gas phase and particulate emissions as a function of different fuels. So it could be diesel, hydrogen, biofuels, etc. The bottom line is we were able to cut 1/3 measurements for the partners. And that reflects into about £1,000 a day to run these operations. If you were to measure us based on a sort of a digital maturity barometer, one can argue we were quite low. Although you can see on the second slide that there is actually a twin and the engine, but we can do better. What we realized critically is that the lessons we learned in terms of combining a domain-specific model, so whether it's physics-based, deterministic, stochastic, etc., that combined with the more abstract digital and knowledge management world. So there were some critical lessons learned. Also, we realized something which has stayed on and helped us, which is if we can connect our models, our software, our experiences with other entities, whether these entities are other pieces of software, other data sources, other companies, other organizations, then we can have much more meaningful impact. And that really was the big lesson learned. And till this date, that lesson has defined our problem space. So our problem space is the lack of interoperability. What I mean by interoperability, first of all, and lack of interoperability across domains. Just to clarify, domains here can mean organizations, it can mean departments or divisions, it can mean different teams across companies, across sectors, etc. And what's the reason for this lack of interoperability? It's mostly because of two things. One is on the right, you see a siloed view of assets. Everyone is bogged down into, rightly so on some reasons and some levels, into their problems today in their sectors. But these are silos. And on the left-hand side, you see an explosion of data, data formats, different devices, sensors, etc. So really, our question in front of us was, can we embrace a connected mindset? Can we connect things semantically and syntactically to have a more holistic decision-making? So, as again, I think John talked about this earlier, which is we decided to follow this using a combination of what I call old AI and new AI. What I mean by old AI are the technologies where we love the internet. So the internet, the semantic web stack, this is what's the old AI. The new AI is everything from deep learning, machine learning, foundation models, etc. So can we really combine all these and realize this connected mindset? So to address this problem, we develop and continue to develop the World of TAR, which is a digital ecosystem powering that connected mindset. So with the World of TAR, or TWA in short, you can connect data, software, and tools syntactically and semantically. You can also query it using industry standard, like, for example, Sparkle, to interrogate across federated data sources. You can imagine and build parallel worlds, so these are scenarios, as well as you can work on optimizing and controlling the base world around us. So this means the world that we live in. So it could be a plant, it could be a city, it could be a country, etc. The users can access these digital solutions via mobile apps, via web apps, APIs, chatbots, dashboards. So let's look at how this works in reality. So this is a district heating network plant in a small town called Pirmasens in Germany on the Franco-German border. And we developed a connected digital twin for this, having represented all the underlying assets, whether it's from conventional energy sources as well as renewable energy sources, the plant operations, etc. So these were, I think, the words such as ontologies was used. So we described everything systematically and consistently with ontologies, mapping with the either existing schemas or the new data sources. And then we looked at about 2 years worth of data. This was real life, real plant operational data. And then we combined that with data from other sources, such as the spot prices for energy, for CO2 pricing, for weather, for energy demand, etc. Again, having secured this, having done this, the client asked us a further question, that is, can we extend this to evaluate what's the impact of this plant on the buildings and residents near the plant. Again, the World of TAR approach, it's scalable and it's easy to bolt on data or information or knowledge from other sectors. We did exactly that. So we combined the building stock representation as well as a third-party commercial software to then emulate and evaluate what would be the impact on the local air quality. The final use case here on the energy side is on the building. So we have looked at mobile devices, we have looked at plant, then on the buildings and cities level. Here the users typically ask what are the energy estimates for the buildings, what are the different renewable potentials, for example. Again, note that the World of TAR, with its scalable approach, is not limited to buildings itself. So it's really at the BIM-GIS interface, but also can include humans and data from mobile sets. Here it's a combination of the BIM, the BMS, so sorry for acronyms, BIM and building management systems, as well as the GIS data. And when that's combined together with wrapping around of third-party software, in this case it's City Energy Analyst, then you get predictions such as these, where you can then have energy estimates, as well as you can then, in here, you can click on a single asset within a building stock, for example, and that gives you a bit more details on, in this case, a solar PV potential for the buildings. With that connected mindset, what this tells you is you can really expand and you can expand your horizon. So what I've presented is, of course, use cases with energy dimensions, but you can go as wild as looking at parliamentary debates, for example, and how are these connected with the use cases. You can look at maritime and what happens if a cruise ship enters a port and what's the impact of that on local quality. Or you can look at self-learning labs, and this is how a lab automation works, how the robots in the lab work. And it's really a Lego-like, where you can start building from a single asset into a multi-asset environment. I'm thankful to all our customers, collaborators in these projects and the projects that I mentioned before. And thank you all, both online and people present here, for your attention. Thank you.
Right, next question over to Amit. Can you tell us a bit more about the parliamentary debate of digital twin? You knew that was coming, didn't you?
Yeah, it's an initial exploratory work, and this is with regards to the handset data. So that's open data, so anyone can work with it, not just us. We were looking at again this combination of old AI and new AI. So things about semantic world, and how can the ontologies, how can the agents, how can the world of TAR help reduce the hallucinations with regards to LLMs, essentially. And the question here was, can we then learn from the parliamentary debates, learn from this data, and can we improve the trustworthiness, the reliability of the answers through things developed elsewhere. And this is a truly ecosystem approach, because we are not the inventors of GraphRag. GraphRag has been developed elsewhere, or classical RAG systems have been developed elsewhere. But the aim was to then wrap around these techniques, to use them and to apply them as a practitioner to reduce those, I think, in a way, uncertainties. Having spent a lot of time on looking at how does new data reduce the uncertainties with regards to predictions, I think in a way that's pretty much what we did. But it's a classic GraphRag feature to reduce the hallucinations.
Right, question to everybody here. How do we bring people along when we're talking about digitalization? Lots of vocabulary and concept is inaccessible, or people just aren't interested. But for example, in energy, it's essential to make stakeholders, including the public, the consumers, comfortable. So what's the best way?
I think really three things. One is, I mean, as David said, right, communication, but equally, to add on to David's point, the interactions we want to have, whether it's a B2B or a B2C customer, we want the end users to be able to interact with, whether it's a digital twin, to see the intervention, to change things, and to have an impact. So that's the communication interaction. I would say, secondly, what really helps with the digitalization path is if you can even, let's say, I won't call it badly predict, but try your best to predict with the uncertainty bounds, the cost base, the cost benefit for each use case. That helps a great deal. And third, I would say, implement and adopt ontologies, but don't talk about them. The reason is that it's just not needed in the dialogue. I think there are domain experts who understand their schemas, vocabularies, taxonomies. They don't need to be taught what their domain is about. You just learn from it, and you take the onus as a practitioner of mapping things. So that's my 3 pennies one.